Wireless power transmission is the method of transmitting electrical energy over an air gap utilizing induction coils from a power source to an electrical load. These coils generate an electromagnetic fields that transmit energy with a perfect governing separation from a charging base station as a transmitter to a coil on a portable device as a receiver. The receiver coil turns the electromagnetic field's energy into electrical energy. One of the examples of wireless power transmission related is Tesla coil. The basic concept that used in this transmission is mutual induction. A Tesla coil is a resonant electrical transformer circuit invented by Nikola Tesla in 1891. It's used to generate alternating current energy with a high voltage, low current, and high frequency. A Tesla coil is made up of two circular coils that are not linked electrically. The primary coil is normally made up of a few turns of thick wire and comes with a variety of shapes. The primary LC circuit is formed by connecting this coil to a capacitor. The secondary circuit is made up of a large coil of wire coiled on a pipe with several hundreds to thousands of turns and arranged concentrically in the center.
For the operation of this circuit, we need to understand that the first main component of the secondary coil, which is made by winding the magnetic enamel wire around any of cylindrical object. Next, the function of transistor is to supply current via main coil, and of course this current can be controlled by connecting a resistor to the base of the transistor. Meanwhile, the supply that we use to power on this circuit is a direct current battery, which is a 9-volt battery. The primary coils that connect to the positive end of the battery is connected to the collector of the transistor, while the emitter is grounded. This indicates that current flows through the primary coil anytime whenever the transistor is conducting. To make the circuit oscillate, one end of the secondary coil is connected to the transistor base, causing which will cause that transistor to transmit an oscillating current into the main coil. The primary coil in this design will create an oscillating current and hence creating a carrying magnetic flux around it. This coil is looped around the secondary coil, which causing a voltage to be induced to the secondary coil. And of course, this is in line with the law of electromagnetic induction. Because of the secondary coil has a much larger number of turns when compared to the primary coil, the voltage will be much higher and the coil will have a strong magnetic flux around it. And of course, to test the presence of the electric flux, we take a light bulb and put it closer to the output of the secondary coil, and we can see that the light bulb will turn on because there is a strong electric flux surrounding the secondary coil output.
The equipment needed to build this Tesla coil are listed as above. This is the circuit diagram that our group used to elaborate the project. The first thing is that take the 20 cm PVC and drill a tiny hole for the coil wire at the top of it. Insert the coil wire through the tiny hole of the PVC and glue at the top hole of the PVC. Then we wrap the wire coil within the PVC with the diameter of 3/4 inch with the total of 300 turns.
Next, proceeding onto the circuit hardware. First, we need to glue the transistor. Then, glue the resistor onto the board. Solder the transistor base leg with the resistor. After that, solder live and ground wire with the switch leg and glue the switch onto the board. take the ground wire to solder it with the other leg of the resistor. Wrap the single core wire onto the PVC as a primary coil. Solder the battery wire with emitter of the transistor.
Next, connect the 9-volt battery and glue it onto the board. Take the bottom end of the PVC and glue it onto the board. Take and fold the aluminum foil become a spear shape. Connect the upper primary coil with the aluminum ball and then glue the aluminum ball on the top of the PVC. Testing and checking the connection of the circuit. Finally, take out the bulb and switch on the circuit. We cannot quite see through the output in a bright room. Let's go to a dark place for a better result. The bulb light up and the circuit was a success.